In today's lesson, we're going to learn about functions. The main standard that I want you to focus on is write a function that describes a relationship between two quantities. Now, in the 8th grade standards, we spent a little bit of time on functions. Now we're going to really dive in deeper on what a function is and how to use them in Algebra 1. Okay, terms to know. Input. Input is your x value. Output is your y value. The value of the input is independent to the value of the output. So that means the output is dependent to the input. Linear function. A function that when graphed makes a straight line. If it is a true linear function, it is a straight line. Nonlinear function is a function that when graphed does not make a straight line. Rate of change. A number that describes how one quantity changes in relation to another. You might also know this as another term, slope. Slope and rate of change are the same thing. A function is a rule that assigns exactly one output to every input. Graph of a function, the set of ordered pairs consisting of the input and its corresponding output. And then initial value, the value of the output when the input is 0, or what I like to call the y-intercept. Your initial value and y-intercept are exactly the same thing. It's where the graph is hitting the y-axis. Terms continued. A relation is a set of ordered pairs, x and y. Inputs are your domains. Outputs are your ranges. The domain and range are sets that consist of values called elements. Now, function or not a function. This relation is not a function. Here's the reason why. This input can only have one output. So since 3 has 8 here, it cannot have the 9. So that is not a function. This one, however, is a function because each input has its very own output. A function can be written as an equation using function notation. Up until this point, you have always seen y equals, for example, 2x plus 1. In function notation, it changes up. That y is gone. That y is now f of x. The notation f of x is read as f of x. It takes the place of y and stands for the output of the function for the input x. So when x equals 2, f of x becomes f of 2. And f of 2 equals 2 times 2 plus 1, which equals 5. Therefore, the pair is 2, 5. Now let's dive into that a little bit more. So if I have f of x, and that equals 2x plus 1. Now let's say I change this to f of 5 equals, what that means is this. That 5 is going to be plugged in as x. So that's going to be 2 times 5 plus 1. That's all it means. When you're going to take that number that is in the parentheses and you're going to plug it into the x value. Now the same function we just talked about can be represented by a graph by replacing f of x with y. Okay, that's essentially what you're doing. You're changing f of x. F of x is now what used to be the y value. The equation can be graphed on the xy coordinate plane, and the set of all the points on that graph is the function. And as you can tell, the slope is 2. That didn't change. And the y-intercept is still 1. Most often, a function is named by the letter f and has an input x. But a function can be named by almost any letter or symbol. For example, a function might be named g of x and a of x, and this might come into play when you're comparing different functions. Now, let's review. Is this a function? In the 8th grade standards, we talked about a vertical line test. A vertical line test looks like this. If I can draw a line straight up and down, and it hits in 2 places, that is not a function. that is not a function. One, because of the vertical line test, and two, 4 and 6 have two outputs. To be a true function, each input has to have its very own output. Does this table represent a function? Yes, it does, because each input has its very own output. Okay, now let's discuss this linear function. H of t equals 9t minus 17 for t equals 4. Excuse me. So really what this means is this. H of 4 equals 9t minus 17. H of 4 equals 9 times 4 minus 17. 9 times 4 is 36. And 36 minus 17 is 19. So in this case, that is what the answer would be. The linear function g of x equals 3x plus 4, and it has the domain -2, -1, 0, 1, and 2. Find the range. Now, quick review. Domain, inputs, your x value, range, output, y values. So, in this case, I would solve for each of these. For example, 3 times -2 plus 4, and I get -6 plus 4, and I get -2. Three times -1 plus 4, -3 plus 4, and I get +1. Three times 0 plus 4, I'm going to get 4. And I would keep going on and on and on. I think you get